You are provided with 0.1 capital M sodium hydroxide solution F. So this one is 0.1 capital M sodium hydroxide called solution F. Solution G is made by dissolving 23.46 grams of a diabasic acid in 250 centimeters cube of distilled water. Very important. Kuna kitu hapa nataka ujue. I want you to know what is a diabasic acid. We have monobasic acid. Examples of monobasic acid is HCl. It has got only one hydrogen. Monobasic. Nitric acid. Monobasic. Diabasic is an acid like sulfuric acid. So this acid here is an example of sulfuric acid. So if you know how to write equation with bases using sulfuric acid, this one is not going to give you a problem. So this diabasic acid was dissolved, 23.4 grams of diabasic acid was dissolved in 250. Very important that this is the mass in 250, not in 1,000, but this mass is in 250 centimeters cube. So you are required to determine to dilute solution G, standardize that. So we are going to dilute this solution G. Procedure 1. Using a measuring cylinder, measure 20 centimeters cube of solution G and transfer it into a beaker. Measure 80 centimeters cube of distilled water and add it to the 20 centimeters cube of solution G in a beaker. Label the solution H. Understanding the procedure or whatever you are doing is very important. We are taking 20 solution G, add 80 centimeters cube water, distilled water, and forming 100 centimeters cube solution H, because 20 plus 80 is 100 H. So this H we are forming here, the total volume is 100 centimeters cube, kwa sababu ni 20 G plus 80 centimeters cube of distilled water. And what is H? H is the diabasic acid G. Remember that. H is a diabasic acid G, but diluted now. Procedure 2. Place solution H in a purate. Pipette 25 centimeters cube of solution F into a 250 centimeters cube conical flask. Add 2 to 3 drops of phenolphthalein indicator and titrate with solution H. Record the results. So the results was recorded and we have 14. So let us complete the table. Because we have been given to one decimal place, we will take our initial to be 0.0, 0.0, 0.0. You subtract here, it is going to be 14.1, 13.9, 14.2. So calculate the average volume of solution H. This is the solution of H that was used. So the average is you add this plus this, divide by 3. So our average is 14.10 centimeters cube. Determine the number of moles of solution F in 25. F is sodium hydroxide. F is sodium hydroxide. We have the molarity. Molarity is the number of moles in 1,000. This capital M stands for molarity, and the molarity is the number of moles in 1,000 centimeters cube. So we know that is 0.1 solution F, 0.1 moles actually, moles of solution F are contained in 1,000 centimeters cube. F. what was the volume we used? We have been given it is 25, so we will ask 25 centimeters cube. F will contain how many? 25 times 0.1 divided by 1000. This one will give us 0.0025 moles. So this is the number of moles of sodium hydroxide that reacted with H. Determine the number of moles of acid in solution H in the average volume. Remember this H, we don't know anything about H at all. We only know about the volume. It will be 100. So for us to know some information about H, we must write the reaction between H and F. So the reaction F is sodium hydroxide. So it reacted with H, which is H2MO6. This one here. I told you this one is like sulfuric acid, so you write the equation the way you could have written using sulfuric acid. So you will have sodium sulfate. Instead of sodium sulfate, you write MO6 plus water. It is a salt plus water reaction because this is neutralization. But since sodium here is 2, you balance by writing 2 here, and that is it. The volume for this one is 14.1. The volume for this one is 25. Na tuko na moles yake. The moles of this one is 0.0025. So we are asking the moles of H. This is H in the average. So what was the number? So because the ratio here now you can see the mole ratio of sodium to H2MO6 is 2 to 1. Fine. So meaning that the number of moles of the H acid here is going to be a half. So we are going to, this one is equal to 0.0025. You ask 1 will be what? This one. That is 1 times 0.0025 divided by 2. So the moles of the acid that was used is 0.00125. That is the number of moles of H. Sawa? So it is important to kuandika equation, ujue kuandika equation na kubalance. If you don't know that, then it becomes very difficult. Determine the number of moles of acid in 100 centimeters cube of the solution H. Now we know the number of moles of H in 25. Is it in 25 in 14? Because H, the average volume is 14. H, the average is 14. So this moles is the moles of H in 14 centimeters cube. So 14.10 centimeters cube contains 0.00125. We will simply ask what will be 100 centimeters cube. H will contain what? So we simply this other 100 times 0.00125. We divide by 14.1. That one gives us 0.00865 moles. This is the number of moles in 100 solution H, 100. Determine the number of moles in the acid in 20 in the acid in the question starts here. Determine the number of moles in acid in 25 of the acid in 25 centimeters cube solution G. So you must know what happened. We measured 25 centimeters cube of solution G, diluted it to 100 centimeters cube solution H, meaning that the number of moles in 100 centimeters cube solution H will be exactly the number of moles in 20 centimeters cube solution G, the original. So number of moles in 100 centimeters cube solution H will be equal to the number of moles in 20 centimeters cube solution G. So moles of 20 centimeters cube G will be equal to 0.008865 moles. This one here, because this is the number of moles of H in 100. Number of moles in 250 of solution G. That's very simple now that we know the number of moles of G in 20. So 20 centimeters cube G contains 0.008865 moles. Right? So we will ask 250 centimeters cube G will contain 250 times 0.008865. We divide by 20. And this one gives us 0.1108 moles. So this is the number of moles in 250 G. Calculate the molar mass of acid. The molar mass. Molar mass is the same as RFM. Fine. So there is two ways we can do this. So we can use method 1. We know the number of moles in 250. 250 centimeters cube contains 0.1108 moles, right? And what was the mass in here? We were given the mass in 250. So the mass 23.46, this was the mass also in 250, and it contains 0.1108 moles. So 1 mole will contain what? So that is 1 times 23.46 divided by 0.1108. This one gives us 211.7, and that is the mass in grams per liter. You can simply say RFM is equal to mass over moles. That's what I have done. Method 1 is RFM is equal to mass, this is mass of RFM in 250. So, or method 2, we can get the mass in a liter. So 23.46 grams are in 250 centimeters cube. 1000 a liter centimeters cube will contain how many? That is 1000 times 23.46 divided by 250, and this one will give us 93.84 grams per liter. That is the mass in grams per liter. But we know that molarity is equal to mass in grams per liter divided by RFM, meaning that RFM is equal to mass in grams per liter divided by molarity. Right? So molarity will be, you ask, if this is the number of moles in 250, what will be the number of moles in 1,000? 1,000, it will give you 0.4433. So that is 93.84 divided by 0.4433, and that one will be 211.1.71. Determine the mass of M in the formula this, given that H is equal to this and that. So, but we have the RFM. RFM, which is the molar mass, is equal to, we can round off this one to 212. We can round off this 212. So, H2 MO6 will be equal to 212. To 212. H is 1, so 1 times 2 plus M plus 16 times 6, the answer is 12 to 12. So this is 2 plus M plus 96 will give us 212. So we can like terms together. So M is equal to 212 minus 2 minus 96. So M is equal to 212 minus 98. So M is equal to 114.